Good morning, fifth graders. Hello there. It's your friendly math teacher here. I know you're super excited. Another video from Mrs. Montijo. We're going to do more math, more volume. So we're working on gardening at my house. I'm trying to be better in my yard since I can't go anywhere. So that's what this lesson is all about, building planters for your garden. And it's going to give you guys practice on drawing your rectangular prisms, okay? So the first problem is Jeffrey's first planter is 8 feet long and 2 feet wide, okay? The container is filled with soil to a height of 3 feet in the planter. What is the volume of the soil in the planter? Explain your work using a diagram. So I drew my planter, okay? And you'll notice that I drew the base of it 8 feet long and 2 feet wide, okay? Now, I knew the soil was 3 feet in the planter, but usually with a planter, if you've ever done any gardening, you know that that soil does not come all the way to the top. So that's why I drew my planter a little bit larger than or taller than just the 3 feet of the soil. So just to refresh your memory on how to draw this, you draw your rectangle, your first rectangle, the length that you want your prism to be, and the height, okay? The first, if you're going to draw your prisms the way I'm showing you, your first rectangle is going to be your height and your length, okay? And then you're going to take you're going to get your width by going out in with your parallelogram. Okay, remember we said make these diagonal lines off the corners. Okay, all those diagonal lines are your width. Okay, and then you just connect the two like that. So you'll get lots of practice on that today. But I just wanted to kind of coach you because you're going to be drawing planters of different dimensions today. So just keep in mind, however long your rectangle is, your first rectangle that you draw, that will be the length, and and this will be the height of the prism. Okay, so anyway, I've got an 8 by 2 by, the dirt is 8 by 2 by 3, so I multiply 8 by 2 by 3, and I get the volume of the dirt. Did you guys notice my dirt with all my brown little dots? Yep, I thought that was good. You guys can be creative too. Gotta have fun with this, okay? Have fun. This is my dirt. If you want to, you can even draw flowers in there. But the volume of the dirt is 48 cubic feet, okay? Now, he is going to grow tomatoes in 4 large planters. See, he's a serious gardener. He knows that he needs a lot of tomatoes, so he needs 4 large planters. He wants each planter to have a volume of 320 cubic feet. So he knows the volume he wants, but he wants them all to be different. See, he's very creative. He likes everything to be, a little bit different. He doesn't like everything to be the same. So you have to think of 4 different ways Jeffrey can make these planters, and you have to draw diagrams with the planter's measurements in them. So, see how I've already gotten a start there? I know most of you are just going to copy this down. Well, I wanted you to think a little bit more deeply about how we're going to get these measurements, okay? So, I need a blank sheet of paper. Okay, cover this up. If Jeffrey knows that his planter needs to be 320 cubic feet, and we have to build those planters, we have to figure out what 3 numbers, we know volume is 3 numbers multiplied. We have to figure what 3 numbers can multiply together to get 320. So how are we going to do that? That sounds hard because we're only in 5th grade. We're perfectly capable of dealing with numbers like this. You guys know multi-digit multiplication. But what I'm trying to get you to break it down into a simpler problem. So don't think about 320 as this giant number. simplify it and think of 320 as 32 tens or 32 times 10. Just look at that 0, that's your clue. You know that 320 is 32 times 10. Now that's only 2 numbers, that's the problem. So we're not quite done. But you can now get creative and think about how to break 32 into 2 factors. Remember, factors are numbers that multiply together to get 32. So think to yourself, what times what equals 32? And what times what equals 10? I came up with option 1. I know that 8 times 4 is 32. And then so you go 8 times 4 times 10, and that's option 1 for a planter. Then I started again with 32 times 10, and I thought, aha, 16 times 2 is 32. So 16 times 2 times 10 could be option 2. Both of these will have one of the dimensions being 10, probably the height, or probably the width will be 10. I'm just trying to visualize it. Okay, so then we had to come up with another option, and I decided instead of breaking up 32 into factors, I'd break up 10, and I left this option as 32 times 2 times 5. So there was option 3. Now my last option, I was stuck, and so I thought, I can't think of any more ways to break up 32 and 10. 16 times 2, 8 times 4, 2 times 5. So I went back to my original number, 320. I had first divided by 10 to get 32 times 10. So then I thought, well, what else could I divide by? If it ends in 0, I know it'll be divisible by 5. So I divided by 5 and I got 64. And I thought, okay, 64 times 5 is 320. What times what equals 64? 8 times 8. And I love squares, so I liked that one. And that was how I got my option 4. Okay? So this is a great problem because it's getting you to think flexibly all the ways that you can break up 320 into 3 factors. Okay? So here I've drawn the planters for you. You will have to draw them yourself because you have to take a picture. Ha! So you are going to have to draw these. And it's good for you because it really helps you think when you can draw in 3 dimensions. So just to go over it again, this is how you're going to get started. You're going to draw so this is my 8 by 10 by 4. Now think about this. If you're planting tomatoes, do you want your planter to be 10 feet deep? Have you ever seen tomatoes growing? I don't think their roots need to go down 10 feet. So you're probably going to have your planter be maybe 8 feet wide and 4 feet tall. And this is your first rectangle that you draw, an 8 by 4 rectangle. And then your width, or the depth of your planter can be 10 feet. And your diagonal lines go down the 10, and then you just connect the 2. So you guys practice drawing your planters and labeling them. It says, show 4 different ways Jeffrey can make these planters and draw diagrams with planters measurements on them. Okay, so you don't have to draw them the way I did, but when you turn in your work, I want to see the 4 that you drew labeled. Okay. Now, number 3, Jeffrey wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way. So there's more than one way. This is why you want to be flexible. This is just the way I came up with it, so that it is not taller than 3 feet. So if the window is 3 feet high, so that's going to be the height of our planter. So you just know that the height is 3 feet, okay, to start off. But if you need the volume to be 36 and the height has to be 3, then that means the other 2 dimensions have to multiply to 12. okay? So we're saying 3 times something times something, okay? That has to be 12. 3 times 12 will get us 36. That'll get us the volume we need. And we're trying to imagine what those two numbers could be. I just did 4 times 3. You could have done 6 times 2. You could have even done 12 times 1. But that would have been really, really long. So like I said, I did 4 times 3. So I know my height is 4. My width is, my height is 3. My width I made 4. You could make your width 3. But this first rectangle I drew as a 4 by 3 rectangle. And then to get the next dimension, I drew the depth to be, or sometimes we call that the width, 3 feet. And then just connected. So there's my planter. I don't have dirt in this planter yet, so I can just fill it up with dirt. Okay, there is the planter. Okay, 4 times 3 is 12. 12 times 3 is 36. This is an option. Okay, now the last problem, number 4, is after all this gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long, 5 feet wide, 8 feet high. So 6 by 5 by 8. He realizes he needs a shed with 480 cubic feet of storage. Okay, so the question is, will he achieve his goal if he doubles each dimension? Why or why not? Well, we've got to figure this out. Basically, what is the current volume of his shed? What is the volume of the current shed? The current shed is 6 by 5 by 8. So that will equal 240. How did I do that? I'll tell you how I did it. I did 5 times 8 first, which is 40, and I know 6 times 40 is 240. Okay. That's why you want to be flexible. And multiplication, you can multiply in any order. So skip over the 6, multiply the 5 and the 8. Well, actually, I don't know why I'm saying that. You could have done 6 times 5 is 30, and then 30 times 8 is 240. So anyway, 240 is his current volume, the volume of the current shed. So they're saying, will he achieve his goal of 480 cubic feet if he doubles each dimension? Okay. So he's going to double the 6, double the 5, double the 8. Look what the new volume is. That is way too much. Okay. This is very interesting because you would think he would, or you might think, since you're in 5th grade, right? You haven't had a ton of experience. If his current volume is 240 and he wants the new volume to be 480, can you see that 480 is double 240? So he thinks, okay, I've got to double everything. But what happens is if you double 3 numbers that are being multiplied, you're actually getting a volume that's 8 times his current shed. Okay? You're getting a volume that is way bigger than what he needed. 240 times 8 is the 1920. So really, he only needed to double one of the dimensions. Okay, but we'll get to that. If he wants to keep the height the same, what could the other dimensions be for him to get the volume? So he likes the height of his shed, and he wants the shed to stay at 8 feet. Now, does that make sense in real life? I would say yes. Think about a shed. You want to be able to walk into it, right? So you may or may not know this, but 8-foot ceilings are kind of a good height to have because, think about how tall people are. There aren't a lot of people most people are not over 6 feet tall, but you could have a few. My son's 6'2", but most people are not over 7 feet tall. So you want to be able to walk into it. So an 8-foot ceiling is good. And then if the height stays at 8 feet and we need 480 cubic feet, we're going to divide the volume by the height to get 60. And what that tells us is that the other two dimensions, the length and the width, have to multiply to 60. So what numbers multiply to 60? I came up with 4 times 15, 2 times 30, and 3 times 20. So these were all my options for the dimensions. You may have thought of some others. And then if you use the dimensions in part B, one of these, what could be the area of the new shed floor? Well, I just went with 15 by 4 because I really don't want a long and narrow shed. 2 by 30, if you think of the floor being only 2 feet wide, you could barely get in there. And it'd be super long. Same with 3 by 20. So I think 15 by 4 was the best option. And that will give us an area of the floor of 60 square feet. Okay, that's it. Good luck on the problem set. Please come to office hours and say hello. Please take your time with this. Do your best work. Take time in your drawings. Have some fun with this. You will be so happy if you learn to draw in 3 dimensions. Okay, it'll give you a leg up on a lot of people that never learned how to. All right, have a great day, 5th grade. Bye.